we've got a polynomial f of x and three statements, and we're asked which of these are sufficient for the equation f of x equals 0 to have a real solution, i.e. which of them imply that f of x equals 0 has a real solution. So if we have a cubic equation, a cubic polynomial rather, and we set it equal to 0, do we have to have a real solution? And the answer is yes, because it must start either at minus infinity or end at positive infinity. So at some point it's got to cross the axis. It may cross more than once, but we're just interested in having a real solution. Or if it was a negative one, it's going to have to cross to get to here. So 1 is sufficient. Then in the second one, we're not told it's a cubic anymore. We just said there's a real number t for which the stationary point is 0. Does that guarantee that we have a real solution? Remember I said it's not necessarily a cubic now. So what if I had a quadratic? I could just have a quadratic polynomial that goes like this. Then I would get a stationary point, but I wouldn't get a solution to f of x equals 0. So this one is not sufficient. Which leaves us with the final one. There are real numbers u and v for which f of u times f of v is less than 0. So what that means is that we must get both positive and negative values of the function. Because if they're always all positive, you could never multiply them together to get a negative, and if they're always all negative, again, same thing. So we've got to have, say, a point down here and one up here. And again, because it's a polynomial, it's got to be continuous somewhere in between. It's got to go through 0. And therefore that one is also sufficient, which means our answer is going to be C. Nice one.